Right, this is part 2 of those simple molecular compounds. We had this up last time and we were talking about these being dot-cross diagrams. And then just to recap a bit before we move on to their properties. So if you look at hydrogen here, you've got one each needed, so they share it, and therefore they've got a full outer shell because they need 2. And we said that the stick diagram means they share one each, therefore there's one line. And the formula is that there. Okay, for this one then, they also need one each, so there's one between them there. Again, one stick and F2 because they're sharing one each. Fabulous. Then we came on to carbon, which was a bit more tricky because it needed to share 4 and these needed to share 2, so therefore they share with 2 lots of O. And if I drew that out in a stick diagram, I'd have I'm sharing 2 each on that side to that O and 2 each to that one on that side, and this would be CO2, our favourite carbon dioxide. And then if you had a go at this, let's check if you got it right. Fluorine needed 1, carbon needed 4, so you need 4 of these all sharing 1, and our stick diagram would be 1 carbon there, and then we'd have our fluorines all sharing 1 around the outside, and the formula would be CF4. Fabulous. Now let's have a look at your properties. Now the ionic properties are about melting points and boiling points and electricity and how they conduct it, and this is the same. That's the sort of thing you need to remember, and these are slightly different. I've sort of put some bubbles up here because they're a bit like bubbles, these simple or molecular compounds. They stick together, so here is our molecule, and they quite like each other, and they're not really interested in anything else. These like each other, they're not interested in anything else. Hence our beautiful picture of couples here. So here is a molecule, they love each other, not interested in these people. They love each other, not interested in these people. They love each other, not interested, and so you can get at the point here. So simple molecular compounds have weak forces of attraction between the molecules. So here is my molecule. They've nothing to do with this one here. Okay, nothing to do with it. So weak forces between the molecules, that means that they can separate out. If I said then, like, here's one molecule. Let's make it pink. Grey. Okay, now there's one molecule there, that pink thing, and here's another molecule. They would just separate off, it doesn't matter at all. So there's a very weak force of attraction between the molecules. Look, they're not interested in each other. Now that is called weak, that's right, intermolecular force. And because of that, it takes very little energy to move them apart. So they have a low melting point and boiling point. I should have used a pen there, it's getting a bit silly with the mouse. So weak forces of attraction between molecules is weak intermolecular forces. So they spread apart. If you imagine a solid, they're all close together. With these weak forces, they're not really like each other. They move apart really easily. You haven't got to heat them up for ages because they don't really like each other anyway. So they tend to be gases or liquids. However, between the molecules, like here, between those, there's really, really strong attraction. So you can't sort of split them apart like you would with the ionic compounds. You can't split them apart. You can just move the molecules, but you can't split the atoms apart. Very strong forces of attraction within the molecule. They love each other here. You can't get them apart for love nor money. Yeah, but it doesn't matter, it still gives them a low melting and boiling point because they will separate out here. These two here are separating out, so they have a low melting point and boiling point because the molecules will move apart. They have weak forces of attraction between the molecules. They also don't conduct electricity because they're neutral. There's no movement of ions, there's no charges or anything like that. So the molecules are neutral, so they don't conduct electricity. Oh my goodness me, that's always it. And your pen goes totally doolally. Okay, don't conduct electricity. Love this board. Right, so they have weak, low melting and boiling points, and they don't conduct electricity.